So before starting, I'm gonna ask, hi Raphael, welcome. This is your first time also. Okay, hopefully you enjoy it and hopefully you come back. So before starting, I want to ask, okay, literally, I think I've not seen anyone here that said they've joined before, so I'm probably going to skip that question. So because literally what we do is we also have, I should mention that we also have this GitHub page, this GitHub repo we used to track the series. So even if you missed other parts of the series, or you feel like you want to check on things we've done before, what we've talked about before, you can always come here. I'll drop the link on the chat. It's kind of a bit organized. We try our best to organize it. And you can also use it as a kind of refresher course, or if you need to like prepare for an interview and you just want to refresh your mind. So everything is like kind of arranged. These are the concepts we talked about so far. And then if you go to each of this concept, the last time we talked about stacks and queues. Now we just do like the same thing we discussed right now for 20 minutes, just a brief overview about it, just kind of refresh your mind. And then there are also resources for you to read up more if you feel like you want to go in depth, understanding stacks, understanding queues. And we also have this practice questions. This one is like quite important because it's a practice question on that concept you're talking about. These are questions and stacks and queues you can use to, practice, because you learn more by practicing, we all know, right? So you can use this to practice, and we encourage strongly that you send us a PR of a solution. So if you see here, many people have. So what you just do is you fork this repo, and then you add your solution to this practice solution page, depending on the like concepts you are dealing with. Now, these are practice questions people have submitted, some people have not yet. So like if we go to maybe, is it like hash tables? Yeah. So you get to see some questions that have been submitted by some people. So the format is just that you write the name of the question and then you put your username, then dot whatever, if it's in javascript.js, in c#.cs, or in python.py, or those kind of things, then you just submit the PR. So we encourage you to do that so that other people can learn from your solutions, and you can also learn from other people's solution, when you get here. So that's what we have right now. We just have this repository for tracking every single thing. You can always use it to, check what we've talked about before, or even if you just want to come back here to just refresh your mind and all that, just like a refresher course. Let's say it like that. So let me drop the link on the chat while we are talking. Okay, yeah. So I'm gonna get started, yeah. Back to my slide. Okay, so again, welcome. Today we are talking about sorting and searching, and this is like an important topic when it comes to either dealing with technical interview or even dealing with natural day-to-day life. If you are a software engineer, if you're a programmer, you are literally sorting and searching in some ways when you write your programs. So it's like an important topic to discuss, deal with, and also refresh your mind on it. Like I said, it's just a refresher course. I'm not going in depth, but we would provide resources you can use to like read up on it if you feel like you want to read up on a particular algorithm, or you want to learn more about a particular algorithm. I have provided some good resources I think is amazing. You can also, fork the repo, add some amazing resources you have come across, and also send us a PR. That's also acceptable. So common sorting algorithm, starting with sorting, these are like the common ones I know, or I think that people use frequently. Not all is used, but they are just important to know about, especially when you are preparing for interviews. It's important to know about this algorithms, just in case you see questions. I mentioned one time, and I'm mentioning again. Sometimes interviews don't tell you that, we're giving you a question. This is supposed to be, you're supposed to use so. In this question, you should use hash tables. Nobody's going to tell you that. Or in this question, you should use stacks or queues. Most times they don't tell you that, except if it's written in the question, like if it's vivid in the question. Or they will say, in this question, you should use insertion sort or merge sort. Nobody's going to tell you that, except if you can see it in a question. So it falls on your side. So first of all, understand the pattern and understand what is this question requiring from you. Where is this question going to? This sounds like this question wants me to use that step. This sounds like, okay, I need to use insertion sort or merge sort or quick sort here, right? So that's another important thing to note. So when it comes to common sorting algorithms, starting with bubble sorts, this is just, about you are swapping elements until the list is sorted. So you keep swapping and swapping until the list is sorted. Like I said, you would forgive me. I'm not going in depth in this thing because these things are topics on their own and they can take 1 hour literally. But I've provided this resources and I still read up on it yesterday. It's so nice. This is the first link. It literally goes in depth into explaining each of these algorithms. So they would explain step by step for you. So if you feel like you don't know so much about one of them or most of them, please just come here. And it's quite short. It's not so long and they are not making a lot of drama, but it's really nice. So you can use it. So back to what I was saying, just like I said, bubble sorts is just about you're swapping elements until you are kind of swapping elements and then pushing them to the end of the stack, or to the end of the list. So you keep swapping until all the largest elements are floated down to the end of the list, right? That's just the summary about it. And for selection sorts, that one, you're selecting a minimum and you are moving it to the front. So more or less you go through the list, looking for the minimum, then you move it to the front. Now go to the remaining part of the list, look for the minimum, move it to the front, just like that. So you keep selecting the minimum from the unsorted part of the list and moving it to the front until the list is sorted. That's just the way selection sort works. You're selecting minimum. For insertion sort, this one is quite nice because what you do is you are assuming that a list will be sorted, right? So meaning you're assuming that the first element is in its position, it is sorted. The first element is in the right position. And then what you just do is insert every other element in their proper position by shifting elements when needed. So it's more or less I know that if you come here, so it's more or less in insertion sort. So it's I'm going to assume 9 it's in its proper position. Wow, this is a bad example. This is a worst case. So if I'm assuming 9 is in its normal position, I'm just going to, start from 5, you pick 5 and you try to insert it in its proper position. 5 proper position is supposed to be in front of 9, right? So you're just going to move 9 to the back and put 5 in front of 9. Now you take 1 and try to insert it in its proper position. At this point, 5 it's in front. So this is what we have right now, 5, 9, 1, 4. So you pick 1 and try to insert in proper position, which is in front of 5, right? So you just move 9, 5 to the back and then put 1 in front of it. And then you keep doing like that. You pick an element, move if necessary, so that you can insert in their proper position. Like if you check here now, when you pick 4, and you want to insert it in its proper position. 4 is supposed to be in between 1 and 5, right? So what you just do is move 9, move 5, and then you just put 4 in the middle in between 1 and 5. So you just keep doing that until the list is sorted. As you can see, this is a bad case. And for you to sort this element, you will literally have to go through this list n square time. So for for each element you pick, you will probably have to shift each of the elements every single time. So that's what we meant worst case. And that's why it's important to know their complexity also. Most of sorting algorithms, worst case complexity is like n square, I think, except for merge sort. So you should know their complexity. I think I'm going to mention that later. So, and then we have quick sorts. That's also another one of variant. We have merge sort, which is also another important one. Merge sort is all about divide and conquer. So that one, you just keep dividing your element until you have like one or two elements left. So like here. So you keep dividing your elements until, more importantly, they use kind of recursion here. So this is where, I think this is like the first time you encounter recursion. You have to understand recursion to understand, how merge sorts literally works. But what they are just doing is, dividing the list or into smaller parts until you have like one or two elements. Until you have one element left, actually, and then you kind of build it back up. So, but while building back up, you kind of create a new list, and then you sort into that new list. So, like, if you have like divided all your elements up to maybe you have 6, you have 5, you have 12 left. I'm talking about this first half. Now, what you just do is you build back up starting from 5 and 12, and you just pick first element 5 and 12, which one is greater, you kind of sort them. So you have the sorted list of 5 and 12, and you have 6. So you sort 6 and also 5 and 12 list, you build it back up. But while building, what you just do is take the elements one by one and then be arranging them into that list. So you take element A from list A and element B from list B and kind of sort it into a new list. So you're building your list while you are going back up. I am not explaining well, I know, but like I said, come back here and understand the algorithm if you want to. It's like an important algorithm. Now, the other one we have is quick sort. Quick sort, what it does is that you are kind of selecting a pivot. So you are selecting an element kind of, and you are arranging every other element in the list around that pivot. So like this one, they selected the pivot as 2, right? And then you tend to arrange every other element in this list around this pivot such that when you arrange 2 where it's supposed to be, elements in front of 2 should be lesser than 2. Elements at the back of 2 should be greater than 2. Then you keep doing that same thing. Now, like this list now, 2 is in the proper position, right? So you keep doing the same thing from 8 to 6, you select a pivot also and rearrange it. From 1 to 0, select a pivot 2 and arrange it. So it's still also a divide and conquer algorithm like merge sorts. But I think the difference here is that we don't create a new array. We don't create a new merged array like merge sort. So this does not use like extra space the way merge sort does. The only extra space it uses is the fact that you have to do recursion and then you have to keep track of the recursive list. So yeah, that's the extra space. But like it doesn't create a new array when building or to merge or do anything, unlike merge sorts. And the also last one I want to talk about is counting sorts. For counting sorts, I like to explain it this way. So what counting sorts is that you are recreating elements. So you literally just pick all these elements, right? And then you count them. So it's like, oh, I know that you first check for the maximum element. The maximum element is 8. Create an array of 8 index, like an array of length 8, and then for each of these index you count the element that's related to it. So like this one now, you count how many ones do we have, you put it here, and I think this is the list we have. So we have 1 1 2 2. So, and after having this, I jump. After having this, what you just literally do, recreate the elements again. Just create a new array, put in whether you have put in 1 where it's supposed to, like 1 is going to be in front of the array, right? And then you have 2 2s create 2 2s at the back of 1. You have 3 2s. We have 2 3s. Create 2 3s at the back of 2. Then another 4 at the back of 3. That's just the way I would do. Like, when I get here, I skip whatever else they're talking about and I get to this point. So that's the way I like to explain my counting sort or something. Because there are some questions that even deal with that, where they give you a question and they say, sort a particular thing, and you can literally use count and sort. Count the number of elements that are there and then recreate them again. It's like, gives you order of n. I think this is like one of the best algorithms, sorting algorithms that gives you order of n, that gives you like linear time complexity. So yeah, those are like the algorithm I wanted to touch on. Like I said, please go back to any of these links to kind of check on the algorithms again. If there's anyone you don't understand fully, even I myself had to go back to kind of read on it yesterday because, like I said, I've forgotten about it. So you can always go back to the link I provided. It's like really quick, which is one thing I like. There's not too much stories and they explain it like really simple and really easy. So that's what I'm going to say about sorting algorithms. Now we are going to deal with 2 of the sorting algorithms today in your breakout rooms. Your facilitator is going to explain more when you get to your breakout rooms. So whether it's beginner or intermediate rooms, we are going to deal with one of these algorithms to answer the question that is given to you. And like I said, most times they don't tell you what you're supposed to use. You're the one that will figure it out. That based on what I'm saying, based on the pattern, I can see that I'm supposed to use this algorithm, right? So now searching algorithms, just like sorting, we have some common searching algorithms that allows you to search efficiently. And one of them is linear search, which is you just searching sequentially. You're just going from beginning to the end until your element is found. While for binary search, it's also like a divide and conquer kind of thing, where you are splitting the array such that you are reducing the search space. So you check what element are you trying to look for. If it doesn't, most apparently this is done on a sorted list. You can't do it on an unsorted list because what you're assuming is that the list is sorted, and when you are given an element, you can easily check that would this be found at the end of the array or at the beginning of the array or at the middle. So based on where you think it's going to be found, you can just reduce your search space and just keep searching that way. Binary jump search too. And this search algorithms, they were explained in the link I showed you earlier also. This jump search, I don't know if it's common. I don't think it's common because I just saw it yesterday. So it's just about you skipping over a fixed size of elements and searching. This also works on sorted arrays too, where you just skip. So you have a sorted array and then you have the element you're trying to look for. When you start from the beginning, you can feel like, okay, if I don't find this element at the beginning, skip over like maybe 4 elements, take the 4th element. If the 4th element is greater than the element you're trying to look for, you know that, okay, it's probably between this 1st and 4th element. Or if the 4th element is, if the fourth element is smaller than the element you're trying to look for, like the key you're trying to look for is greater than the 4th element, then you can jump again. So that's just it's just like binary search, but the difference is that you're not doing that, racking your brain over algorithms and understanding, okay, what's the formula for binary search? You don't have to think about that. That's just what jump search is. And when to use, this is important. So before I jump to when to use, please, importantly, things to know how these algorithms work. It's super, super important. You don't want to get to your interview and you have to search the formula for how binary search work. You have a binary search question, you're like, is it I plus low over 2, or is it medium plus low minus medium over 2, and all that kind of thing, you don't want to do that. So know how these algorithms work. And one way you can know them is, like I say, implementing them. So try and implementing these sorting algorithms. You don't implement linear search, but you kind of make use of that. try to make use of them, try to understand how it works, understand their time and space complexity. Please do, it is important. And I already shared the link, especially for the sorting algorithms. They just gave this overview on, best case, worst case, the average case. It's important to know them so you know when to use what, especially when it comes to space. Are you trading off space over time, or those kind of things? Please know their time and space complexities. And so now I have a question for you. I still have some more time. So I want you to answer me on this question, when to use what. Now, when you want to search in a sorted array, what do you use? You're given a question and they say, so it is relating or it's sounding like search in a sorted array. What comes to your mind? And feel free to unmute. I think you can unmute. Yes, you can unmute. So unmute and tell me.
Search or jump search.
Nice. Yeah, nice. What about when you're searching in an unsorted array?
Then that would be linear search.
Okay. Or?
I think that's the only one I know for unsorted arrays.
Okay. Anyone else? When you're searching an unsorted array, what comes to mind?
Is it binary search?
Binary search works for sorted array.
Okay.
Or you could sort it and use binary search.
Exactly. So again, you have to do trade-off anyways. If you feel like, what's the cost of sorting it and then using binary search, or just using linear search, those are trade-offs you have to think about. And that's something you can discuss with the interviewer. I can be like, oh, I'm thinking about this, but I'm also thinking about this, and I'm trying to weigh the trade-off. It allows you to know that, it allows them to know that, okay, you are broadening your horizon. You are just not fixed mind. You're not cramming this thing, right? You know what you're doing here, that kind of thing. So yes, you can always sort the array and then use binary search. Now, where you want to insert into a sorted array, what do you use? What comes to mind? Hello?
Sorry, can you repeat the question again?
So I said you want to insert this third question here. You want to insert into a sorted array. And by the way, I'm coming. Let me. Okay, yeah. So yeah, I said when you want to insert into a sorted array. So you have a sorted array and you are given an element, like an element K, insert into a sorted array A. So what comes to mind? What is that? What is the algorithm coming to your mind on what to use? Like I said, nobody's going to say, if they give you this question, they're not going to say, use this algorithm. They're just going to say, given an element, given a key, K, insert it into a sorted array, so. That's all. But what is the algorithm that's coming to your head?
I guess you can first use binary search to know where that particular element would fit in.
Mm-hmm.
And then you can use maybe insertion sorts. I'm not sure, but yeah.
Nice. You're on the right track.
Okay.
But instead of using binary search to know where to insert, you can just literally use insertion sort straight up.
Oh, okay.
Because you know what insertion sort does is it tends to compare. So you have the array. So like you have maybe like array 2, 3, 7, 6, 9 already, and you are given insert a key of 7. What it just tends to do is that, okay, I know that my key is 7 and I'm trying to insert it into the right position here. It tries to compare it with each of these, elements. And then when it gets to the position, it moves the elements down. So it gets to 9. And then it tends to move 9 to the back and then puts 7 in the right position. Okay, so I think here you are right. Using binary search to search for where it's going to be instead of this linear search can kind of reduce the time also. So we kind of use binary search. I know that it's supposed to be in between 6 and 9. And all we just do is like insertion sort, move the 9 backward and just put the 7 in the position. So yeah, you're right. Okay, so I'm gonna say binary search. So what about next question? You are merging 2 or k sorted arrays. What comes to mind? And please let's be fast so that we can go to our breakout rooms.
Bubble sort. I'm not sure.
That's one way to do it. That's what, the important thing is, these algorithms or these questions, you can use several ways. You can use several things to do it. But again, we always like to minimize time and space. That's like one important concept in programming. You always try to, because your resources are limited and time is also limited. You don't want your users to come to your space or to be using your program or software and then they have to wait forever, So we always want to reduce time and reduce space. So you can always use any algorithm, but importantly, you just think about, is there a way? Is there any other algorithms that allows me to reduce time and reduce space? So bubble sort is one way, but for bubble sort, I have to swap. So meaning if I have 2 case sorted arrays right now, I have to merge them first, and then I have to start swapping, all just because I want to float the elements into the right position. But since I already have 2 arrays that are sorted, and all I need to do is merge them into a sorted array, what comes to mind?
Merge sort.
Exactly. Thanks. So someone said insertion sort on the chat because it's already sorted. Yes, insertion sort because it's already sorted. Remember, both lists are already sorted. So literally for insertion sort, you have to pick one element from one list. You have to use one of the lists. So if you have 1, 2, 3, 4, and you have 5, 6, 7, 8, for insertion sort, you have to pick 5, put it in the right position in this list, right? You have to move in it. Pick 6, put it in the right position. But for merge sort, there's already a way to know that, okay, even though all we have to do is create a new array, which you would end up doing anyways, because probably this array is fixed for this guy, this array is fixed for this guy, so you end up having to have a new array. And for merge sort, you know that you're just you pick one here. So literally how merge sort works is that I have 1, 2, 3, 4, I have 5, 6, 7, 8. So I pick 1 and 5, like both first elements. You start picking from the front. 1 and 5, which one is greater? 1 is greater than 5, right? And then you do, I'm ready to see something. So you kind of put 1 and 5, right? And then you go to the next one, you see 2 and 6. And then 2 is greater than 6. Wait, I have to find where to put 2. I want to put 6. Interesting.
Yeah, hello.
Yeah.
Yeah, I think it's correct. It's correct for the merge sort. Yeah, so I think it's just basically to probe through the first and second one and then align it in one new array.
Yeah. But like now I'm thinking about it. I'm like, if I have to pick two, right now I have 1 and 5 created the new array. This is the new array, right?
Yeah.
I pick the first element, 1 and 5. That one is normal. I can arrange it. First is 1. Second element right now is 5. Now I go to the next one, which is 2 and 6. So I know
Yeah.
2 is supposed to come in between 1 and 5.
Yeah, so that's where it comes up, right? So the index for 5 is not going to move until everything on the left is great until something on the left is greater than 5. That's when the index at 5 is going to move. So it's more like 2 in the indices probing through.
So I'm not gonna put 5 here. It's gonna be like
It's going to choose 1, then check if 2 and 5, which one is greater. It puts 2, checks 3 and 5
I
until
see.
it's one, the first one. Yeah.
So it doesn't just check 1 and 5, it checks all these elements against this guy.
Yeah, exactly.
That makes sense. Wow. Okay, myself, I need to read up. Okay, that's nice. But okay, this sounds like how read up. So you use merge sort here because you already have 2 sorted, elements, and that's literally the way merge sort works. You have to sort each element, building them back up, and it has already done that process for you, or you just need to merge them back. Okay, so interesting. I need to read up on this. And then you have to sort an array that has just 2 types of elements. Now, this one is kind of tricky. What I mean is if I have just elements like A, B, A, B, or like maybe either 3 or 2. It could even be 3. But let's start with 2. So like maybe, and you have to sort them. So you have just 2 types of elements and you have to sort them. What comes to your mind? Yeah, count and sorts. Awesome. That's actually the first thing that comes to your mind because you can easily count them and just recreate them. But what if they tell you you can't recreate? So this one, you literally have to recreate for count and sorts, because what I'm just going to do is I'm going to count A. I'm going to say, oh, A is how many? 1, 2, 3, 4. It is 4. And I'm counting B. And I say B is 3. And then I create a new array. And then I just recreate them. So what if you cannot recreate? Yeah. So that's a question you're going to deal with in your in your breakout room. Yeah, take that to the breakout room. Deal with it with your facilitator. And when you come back, you can give an answer to this one. So with this, we are going to be going to our breakout room. And I would open up the breakout rooms. Now, you tend to choose the breakout room we are going through because I don't know, which one you want to or which one is related to your skill. So we have beginner breakout room. Beginner breakout room, literally, you solve easy questions, but in intermediate breakout room, you solve medium, sometimes hard questions. So you choose your struggle. Choose the one you can bear. So if you are starting out and you're just new to all this, I would advise you to choose breakout room beginner. I'm going to open the breakout room now, and then you choose where you're going to. But for beginner breakout room, I can move you around because since we have 2 rooms, you can reduce the burden on the facilitator, So, and in each of the breakout room, you solve different questions. As usual, we used to solve the first question first. Then if you have more time, you solve the second question. But based on experience so far, I don't know. Most times we don't solve the second question, but just in case, So in let me open the breakout rooms. Yes, you can always get the slides. The links are added to the GitHub page already. If you check it, if you check this, so if you check sorting and searching, I've already added all this here already. This is the questions and some more questions for you to, practice. And then these are the resources, and I added them. So we've got you, don't worry. And I'm coming, let me open breakout rooms. Yeah, I open all rooms. Let me assign your facilitator to the right room. And so, like I used to mention, please, when you get to your breakout room, please open up yourself, relate with other people there. You are all here to learn. You can only learn from someone if they open up, right? If they are, if they participate actively, that's the only way you can learn from someone. And the only way someone can learn from you is if you participate actively. So we all have to participate actively, yeah, to be able to learn from each other. So please take that as you're going to your breakout room. Participate actively. The facilitator is just there to guide. We are all here to learn from each other. Don't go there and just mute yourself throughout, please. So, let me see. I don't have. So now you can go to the breakout rooms. I don't have my seconds. Question. So for those who have been listening to the recording, I'm going to pause the recording now. People are going to breakout rooms, and literally we don't record breakout rooms to allow easy active participation so that people can feel free to say whatever they want to say and discuss whatever they want to discuss. I'm so sorry about that, but if you want to join the breakout rooms, attend our meetup. So let me stop the record. So yeah, thanks for joining again. I have the feedback link on the screen. I'm going to drop it on the chat again in case if you didn't see it. So please let us know how today went for you, except from extra time. Don't put, oh, I wish you. Don't worry, we already know that it's a normal thing. We never have enough time. So let us know how we did. And if there's anything we could have put better, we have a Slack channel you can join to ask questions on. Even though people rarely ask questions, like people here are super experts and good. So, but anyways, we have a Slack channel, and most importantly, we have this GitHub repo. So please, visit the repository. I'm going to drop the link on the chat. Visit the repository. Yeah, I'll drop the link to the Slack channel. So, and it's even here. This is okay, I'll drop the link because that's not like complicated. So visit the repository, very, very important. We already added sorting and searching done for today. It's already here. I will add the recorded meetup when it is available. And send us your practice, like solve these questions, right? It can be 1, it can be 2, and just send us your pull request. Send us a request just like this and just say, okay, this is what you're solving. We would be kind to merge it. We want your solutions, in our repository. People want to learn from you, and you also want to learn from people. I'm always a advocate of that. So please, visit this place, check on these algorithms and these certain algorithms to learn more about them. And with that, we are done for today's session. Please come back. Don't after today disappear. If you enjoy the session, come back. I think we're going to have another one in the next 2 weeks, and it's going to be on our meetup page. So feel free to always check. I would always post a message on the Slack channel also. So please come back. We want to see you back again. Give us motivation to keep doing this. You get it? Your facilitators, they don't have enough time. They're doing this out of the benevolence of their hearts. So please make them happy for doing this. So please come back. So with that, thanks for today. Thanks for joining. Thanks for joining, and we hope to see you again in our future or next meetups. Yeah. Thank you.
Okay,
Thanks,
thank
bye.
you. Bye.
Oh, thanks.
Thank you.
Thank you.
Thanks. And thanks to
Bye.
our facilitators today. Thanks. To all the facilitators, please, can you send me the link of your code share, whatever you use today? I just want to get, the solutions you people provided and how I want to add it to the repository. So please send me the link personally, not here.
All right.
Let me stop the recording.